Hello everyone, this is Teacher 𝗢𝗲𝗄𝗏 and welcome to our distance learning on MathPACKS for Grade 9, Quarter 1, Week 3B. The objective of this module is for you learners to be able to transform any type of equations into quadratic equations and solve that equation if it's already in quadratic form. So any type of equations, and that includes rational algebraic expressions or equations. Now when these equations are transformed into quadratic equations, they can be solved using different methods learned in solving quadratic equations. These methods are, to name a few, we have extracting square roots, factoring, completing the square, and the use of quadratic formula. There might be some point in your solution or in the process of solving any type of quadratic equations that an extraneous solution exists. Now, an extraneous solution is a number obtained when solving an equation that is not a solution to the original equation. There are 3 examples in this module, and I left it with you for self-learning, and let me go directly to exercises. We have 10 items in this exercise. Direction: transform each of the following equations into quadratic equation in the form ax squared plus bx plus c equals 0. And then solve for its solutions. Write your answers in your answer sheet or any intermediate pad or bond paper or yellow pad. Number 1, we have x plus 25 over x equals 10. Solution: we have here the first term is x. The second term is a fraction, 25 over x. So we need to get rid of fraction x, or the denominator is x. So we have to multiply both sides of the equation by x. Having done this, our equation now will become x squared plus 25x minus 10x, because 10x here will be transposed on the left-hand side, leaving the right-hand side of the equation to be 0. Then, rearranging the terms in such a way that the powers of x are in descending order. In this case, x squared minus 10x plus the constant term 25 equals 0. The left-hand side of this equation is a perfect square trinomial, and we can factor this out as quantity x minus 5 raised to 2 equals 0. Then we have x minus 5 is a linear factor equated to 0. Then we can have the value of x is 5. In this case, we can say that x equals 5 has a multiplicity of 2, meaning x equals 5 is used twice in the quadratic equation. The required answer for this, number 1, is x squared minus 10x plus 25 equals 0, and x equals 5. Done with number 1. Let's proceed with number 2. The original expression in number 2 is a simple rational expression or equation. 1 divided by x squared equals 16. For the solution, this becomes 16x squared equals 1. And this is equivalent to 16x squared minus 1 equals 0. this side of the equation is actually the difference of two perfect squares. So we can rewrite actually this one as 4x quantity squared minus 1 squared, or just simply 1. Then equate it to 0. Factors of this left-hand side are 4x plus 1 and 4x minus 1. And equate it to 0. These now are linear factors, and we can solve it easily for the values of x. Then the values of x in this particular example or exercise is plus or minus 1/4. The required answer is 16x squared minus 1 equals 0. We're done with number 2. Let's proceed to problem number 3. 2x squared divided by 5 plus 5x divided by 4 equals 10. Solution. This is a fraction. The left-hand side of the equation is a fraction with denominators 5 and 4. 5 and 4 are relatively prime numbers, meaning they don't have common factors. When these denominators don't have common factors, or shall we say these denominators are relatively prime, then the least common denominator that we can have for this is to multiply them. So 5 times 4, we have 20 as the LCD. Having the LCD as 20, so we can multiply both sides, this one, the right-hand side, the left-hand side and the right-hand side by 20, the LCD. Let's do that. So multiplying the first term, 2x squared divided by 5 times 20, then we have 20 here divided by 5 becomes 4. 4 times 2, 8, 10, multiplied to x squared. So 8x squared. The second term of the left-hand side, 5x over 4 multiplied to 20. So it means 20 divided by 4, that's 5. Then 5 here, multiplied it by 5. X becomes 25x. And the right-hand side is 10 times 20, that's 200. But this 200 has to be transposed to the left-hand side, leaving the right-hand side 0. So it's minus 200. Now this equation cannot be factored out, so we use quadratic formula. X equals minus b plus or minus the square root of the discriminant b squared minus 4ac all over 2a. Let's identify the coefficients a, b, and c in this quadratic equation. A is 8, b is 25, and c, the constant term, is negative 200. Substitute this to the quadratic formula. We have negative 25 plus or minus the square root of 25 squared minus 4 times 8 times negative 200 all over 2 times a. Then solving the discriminant, b squared or 25 squared is 625. Minus and plus, we have, the negative 4 and negative 200, that means it's positive. 4 times 8, 32 times 200, that is 6,400. Then we can multiply this, we add this 2, and then let's rewrite this in such a way that one of the factors will be a perfect square. In this case, we ended up with 25 times 281. And this is equal to 625 plus 6,400 all over 16. All over 16. So to simplify, we have negative 25 plus or minus 5 because this will be square root of 25 times square root of 281. So square root of 25 is 5. Then what is left inside the square root is 281 all over 16. So the required answer for this particular exercise is 8x squared plus 25x minus 200 equals 0. And the values for x are negative 25 plus 5 square root of 281 over 16 and negative 25 minus 5 square root of 281 all over 16. Done with number 3. Problem number 4 now. We have x plus 8 over x minus 2 equals 8. Solution. We have here x, and the next term is a fraction with a denominator of x minus 2 equals 8. So the LCD is x minus 2. Multiplying each term of the left-hand side of the equation by the LCD. And so with the right-hand side, we have to multiply it by the LCD. So we have x times quantity x minus 2, that is x squared, minus 2x. Plus the second term, 8 over x minus 2, multiplied by the LCD. We have x minus 2 over x minus 2, that is equal to 1. And what is left is 8. So we have plus 8. Then, minus 8 comes from the transposed constant from the right-hand side. So minus 8 times x minus 2. So we have minus 8x plus 16. And that is equal to 0. Solving or simplifying, we have x squared minus 10x plus 24 equals 0. Now we have to solve for the values of x, factoring out x squared minus 10x plus 24. The factors of 24 are 6 and 4. In which case, we have x minus 6 times x minus 4 equals 0. So, values for x are 4 and 6. So, we have here the required solution. The transformed quadratic equation is x squared minus 10x plus 24 equals 0. And the solution, or the values of x, are 4 and 6. Moving on to number 5. Eight over x plus x equals 9. Solution. We have here x as the denominator in the first term. So we have to multiply both terms and the right-hand side by x. X is the LCD. So we have it here, 8 over x times x. X will cancel out, so that leaves us 8. Then we have x times x is x squared and equals 9x. So we have here 8 plus x squared minus 9x equals 0. Rearranging the terms, we have x squared minus 9x plus 8 equals 0. Factoring out, linear factors are x minus 8 and x minus 1 equals 0. Solving for x equals 8 or x equals 1. From this rational algebraic equation, we transform it into a quadratic equation, x squared minus 9x plus 8 And the values of x that will satisfy this particular equation is 8. And also another value is 1. There are two values of x. Number 6. Number 6 expression, 3 divided by x squared equals 12. Solution, we can cross multiply. So that's actually 3 equals 12x squared. Then we have to transpose 3 to the right hand side. That's 12x squared minus 3. And the left hand side is 0. So rewriting, we have the transformed quadratic equation is 12x squared minus 3 equals 0. We know that 12 and 3 are multiples of 3. So we factor out 3. Leaving 4x squared minus 1 as one factor, equated to 0. Then, divide both sides by 3. So we have finally 4x squared minus 1 equals 0. The left-hand side is a perfect square. The difference of two perfect squares. So we can factor it as 2x plus 1 and 2x minus 1 equated to 0. Solving for x, we end up with x is plus or minus 1/2. So the required or the transformed quadratic equation is 12x squared minus 3 equals 0. Number 7. Four over x plus 1 over x squared equals 25. Solution. We have x in the denominator of the first term, and we have x squared in the denominator of the second term on the left-hand side of the equation. The right-hand side is a constant 25. The LCD is x squared. So we have to multiply both sides of the equation by x squared to eliminate fraction. So doing that, we have 4 over x times x squared. That's gonna be 4x. Plus 1 over x squared times x squared is 1. And the minus 25x squared comes from the constant multiplied by x squared here on the right-hand side, leaving the right-hand side 0. So rearranging the terms, and for me, I feel comfortable dealing with positive x squared. The coefficient of x squared is or should be positive. For me, I feel comfortable doing that. So what I did here is to multiply both sides by -1 and rearranging the terms in a standard form. We have 25x squared minus 4x minus 1 equals 0. And this quadratic form cannot be factored out. So we have to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We have to identify a as 25, b is -4, c is -1. Plugging in the values, so we have x equals negative of -4, that means 4, plus or minus, then we have -4 square that, it's 16. Then we have -4 times 25 times -1. We have positive 100. All over 2 times 25, that's 50. Simplifying, we have 4 plus minus 1 square root of 116 all over 50. We have to multiply 116 in such a way, we have to factor out 116 in such a way that one of the terms or one of the factors would be a perfect square, so that it can get outside of the square root value. So doing that, we have 116 divided by 4. So we have actually factors of 116 are 4 and 29. So square root of 4 is 2. Then what is left inside is 29. So the values for x that will satisfy the quadratic equation 25x squared minus 4x minus 1 are 2 plus square root of 29 over 25 and 2 minus square root of 29 over 25. That concludes our solution for number 7. Moving on to number 8, we have 1 equals 2 over x squared minus 1 over x. Solution. For number 8, it's a rational algebraic expression. So we have to find the LCD between x squared and x. So it's gonna be x squared for the LCD. Multiplying the LCD to both sides of the equation, that gives us x squared equals 2 minus x. Rewriting in standard quadratic form, we have x squared plus x minus 2 equals 0. And factoring this, the factors are x plus 2 times quantity x minus 1 equals 0. Solving for x, we have x equals negative 2 and x equals 1. For number 9, we have x plus 6 over x minus 3 equals negative 4. For the solution, the first term is x. The second term has denominator x minus 3. So the LCD between x minus 3 and the denominator here, which is 1, is x minus 3. So multiplying both sides of the equation by x minus 3, we have the first term is x multiplied by x minus 3. Expanding this, we have x squared minus 3x plus the second term, 6 over x minus 3. Multiply that by x minus 3, cancel out. That means we have 6. And the right hand side is negative 4. Multiplied to quantity x minus 3 will give us negative 4x plus 12. Simplifying, we have x squared equals, the quadratic equation now will become x squared plus x minus 6 equals 0. Factoring out, we have quantity x plus 3 times quantity x minus 2 equals 0. Solving for x, we have x minus 2 equals 0. That gives us x equals 2. And x plus 3 equated to 0, it will give us x equals negative 3. So the required quadratic equation is x squared plus x minus 6 with values for x, negative 3 and 2. Number 10, 1 over 3x squared plus x plus 5 over 3x squared equals 1/9. For the solution, we have 3x squared, so we have to combine because they have the same denominator. So that means these are similar rational algebraic expressions, or in terms of fractions, they are similar fractions with the same denominator. So denominator is 3x squared. Then we combine terms, 1 plus x plus 5, that is x plus 6, equals 1/9. Then Having this expression, we can actually cross multiply. So cross multiplying, we have 9 times quantity x plus 6 equals 3x squared. Then expanding 9 times x plus 6, we have 9x plus 54 equals 3x squared. Then we have 3x squared. Let's transpose all these terms to the other side. That becomes 3x squared minus 9x minus 54 equals 0. Then these three terms have multiples of 3. So factor out 3 will give us x squared minus 3x minus 18. Close quantity equals 0. Then divide both sides by 3. It gives us x squared minus 3x minus 18 equals 0. Then factoring it out, factors are x minus 6 and x plus 3, equated to 0. Solving for x, we have x equals negative 3 and x equals 6. The required or the transformed quadratic equation is x squared minus 3x minus 18 equals 0. That concludes the solution for exercise in this module. Let's consider now the numeracy skill. So we have to solve or to answer the numeracy skill here. What is missing? Copy and complete the table with the missing equivalent value of the number and write your answer in your answer sheet. So we have the column for the fractions, its equivalent percentage form, and it's also equivalent decimal form. For 25%, of course, it is 1/4, and the decimal form is 0.25. For the decimal form of 0.70, that is 70% and 7/10. For 80%, decimal form is 0.80, fraction is 4/5. For 1/3, percentage is 33.33. Actually, you can extend the 3%. Then, we have here 0.33 and less 3 here. But in this case, we cut the decimal places into 2. 1/32 is equivalent to 3.125%. And that is 0.03125. And 0.90 is 90% or 9/10. This concludes our distance learning for this module week 3B. And so long for now. This is again Teacher 𝗲𝗲𝗶𝗁 saying always stay safe and healthy, and God bless you. Have a nice day.